Okay, good morning class. So today we're going to look at trigonometry, sine, cosine and area rule. At this point we have done the revision of grade 10. So today we're going to look at the area rule. This is for exercise 10.2 on page 330. 6. The exercise on 336. Alright. So let's read what they tell us at this point. Up until now, we have worked only with right angle triangles. You all agree with that, no? In trigonometry, we only worked with right angle triangles. Okay. Now we will work with triangles that is not a right angle. In a right angle triangle, the area is going to be half a base times perpendicular. The proof of the area rule. For those of you who want to go learn the proof, you'll find this on page 334, I think. Okay? So we're just going to run through it quickly. And this is not examinable to you guys. Okay? You don't have to go and prove this like we do in Euclidean geometry. We have to prove the theorems. Okay? But I know some of you want to know more than what you need to. Okay? You can go learn and go read up this more about the proof of the sine rule. Sorry, the area rule. Okay? By taking each of the different sides of in turn as the base of the non-right angle triangle, we can derive three different formulae for the area of the same triangle. So if you look here, you use this as your base and DC as your perpendicular. So we know that sine of A, sine is opposite, which is CD, over hypotenuse, which is B, is equal to sine of A. Okay? So remember, if you go, the area is equal to half base, which is AB, times perpendicular height, which is C. With that in mind. Okay? So what they did was they calculated CD in terms of lowercase b. Can you see that? So what they got is CD over B is equal to sine of angle A. And we made CD, which is the perpendicular height, the subject of the formula. So CD is equal to B sine of A. Okay? So the area is going to be AB. But what is also AB? Lowercase c. Can you see that people? So it's going to be half lowercase c sine B sine A, which is half BC sine A. Can you see that people? So if we go with this triangle here, we're on the same account. We get, if you got angle B, it's simply going to be a half A C sine angle B. Can you see that? On the same train of thought, if you're working with angle C, okay, you want to working with angle C, so that will simply be a half A B sine C. Can you see that? So what do we notice in all these cases? What do we notice in what's obvious here? We had two lengths. Remember, this was used here. So we have two lengths and an included angle there. Can you see that? Look here, we have two lengths and an included angle. Again, we have two lengths and an included angle. So for the area rule, we need two lengths and an included angle. If it's not an included angle, then you can't use the sine rule on that triangle. Or the area rule, sorry. Sine rule is in tomorrow's lesson. So, just in general terms, so you can write this down in triangle ABC. Just make it a non-right angle triangle ABC. Because if it's a right angle triangle and they ask you to work out the area, how do you work out the area? Of base times height, if it's a right angle triangle. Okay. So you can write in any non-right angle triangle. In any non-right angle triangle, the area will be, if I know angle A, is going to be of, remember this is B, lowercase b. This is C, lowercase c. This is A, lowercase a. You guys understand? So what will it be? If I got angle A, it will be of BC sine of A. Can you see that, people? What if I know what angle B is, what will it be then? Of AC sine of angle B. What if I know angle C? Of AB sine of angle C. Okay. It just depends what you have, people. If you have angle A, it's of BC sine A. If you have angle C, it's of AB sine C. If you have B, it's of AC sine B. Right. Any confusion so far? Am I moving too fast? Huh? Yes. Where were you yesterday? Huh? Oh, you were in nice. Maybe every day in school, Michael. Now I feel like we're moving fast. Yes? Not done. Okay. So did you watch yesterday's video? Huh? Did you do the homework? Now you... Girls, you guys must take your education into your own hands. I can't stand behind you and make sure that you've done your homework every. At the end of the day, if you're not going to do your homework, you're not going to do well. Okay? That's all I can tell you. Okay, so again, you have to note, I've probably said this already, to find the area of a triangle that is not a right angle triangle, you need to know the length of two sides of the triangle and the size of the angle between the two sides, i.e. the included angle. That is what I highlighted throughout. Not so? Right. Let's carry on. People, example 1 is on page. Example 1 is on page 334. Right, so here we are told, calculate the area of triangle connected to two decimal places. In triangle ABC, angle A is 48, C is 5, A is 7. Is this a right angle triangle? No. Do we have two lengths and an included angle here? Yes. So can we apply the sine rule? Yes. So what do we say? This will be sine of, sorry, the area is equal to of, sorry, the area. Remember? You see, now yesterday when I was doing this, you were sleeping. You see? And today it's filtering into our lesson. What do we have? If we look at this triangle, we have this A. So if we look here, it's as if we have B, not so. So it's going to be of AC sine B. Of AC sine B. If we add this angle here, it's going to be of AB sine C. If we have that angle B, it will be of BC sine A. Now if we look here now, what do we see? We have two lengths and included angle. So it's going to be of BC sine A. If we add this angle and that side, it will be of B A sine C. Why is this A? That's lowercase a because that's opposite vertex a. If you had this angle here, what would it be? Of AC sine B. You see? So do we have two lengths at an included angle? Yes. So it will simply be a half BC sine A. So it will be a half. What is B? 7. C? 5. Sine of? 48. It's 0.5 times 7 by 5 by sine 48. Gives us, to our point, 48. 13. Is that correct? 13.01 centimeters squared. That's the area of that triangle. Is there any confusion there? Alright. Let's go to example 2. Example 2 is on page 334. Calculate the area of triangle correct to two decimal places. Here the triangle is not given. Did not drag it up, cousin. The triangle is actually given. And if the triangle wasn't given, you have enough information to draw the triangle in here. Okay. Let's go. Calculate the area of triangle correct to two decimal places in triangle QPR. QPR. Angle P is 125, which is an obtuse angle there. Q is 148.1 and R is 32.7. Do we have two lengths and an included angle? Yes. So what will the area be here? Area of triangle will be a half QR sine P. Okay, you all agree with that? Alright, so let's go. It will be a half. What is P? 48 comma? Sorry, not P but Q. Times R. 32.7. Sine of? 125. So it's 0.5 times 48.1 times 32.7 sine 125. Gives you 644 comma 21. 21 centimeters square. Is that correct? Any confusion yet? It's easy. No? Is Lala, you okay? See how easy maths is? Go to example 3. We're looking for a nice one to challenge us, no? Example 3 is on page 335, correct? Calculate the length of JK. Let's calculate the length of JK. Triangle JKL has an area of 27. So the area of this is going to be 27 centimeters squared. As you can see the measurement in centimeters. JL is 9 and angle J is 30. Calculate the length of JK. Oh, I marked the wrong one. I marked KL. Hey, Kuala Lumpur. Right. We must calculate KJ or JK. That's what we must calculate. So what do we say? What do we see? We have two lengths, an included angle, and we got the area. Can you see that?
Yes.
So what are we going to do is we're going to work in reverse. Okay. So how do we calculate the area with that information? Area of the triangle is going to be half. So what is this also known as? L, lowercase l. And this is also known as lowercase? Okay. You all agree with that? But I don't need the lowercase. I know this, the name of this length anyway. What is that also known as? JK. Not sometimes. JL. Sine of angle J. See anybody that's confused at this point?
I want to see where it goes.
Sorry?
I want to see where it goes.
You understand where it goes. Alright, what's the area of this triangle? 27. It's equal to a half. What's the length of JK? Unknown. I want to calculate JK. That's your x in this case. JL? 9. Sine of? 30 degrees. How do I get JK on its own? Divide both sides by? There's a whole 50/50 here. Not so. So it's half times 9 sine 50. Both sides. Half times 9 sine of 50. That is gone. So what do we have? JK is equal to? Put that in the calculator. 27 over. A half times 9 times sine 30. Huh? Did I type it wrong in? Oh, the answer is 2. Okay, so that's going to be 12 centimeters. Any confusion? They will do it again. No, she says. Okay. Any questions, people? No?
So,
Yes?
if the area is centimeters squared,
Sorry?
the length is in centimeters, but the area is in centimeters squared, so I understand.
Square. Because when you're looking at the area, you're multiplying the length and the breadth, so it's 2-dimensional. Okay, that's why it's centimeter squared. So you don't square it. That's just meaning to say it's 2-dimensional. That's why when you're working out volume, it is centimeters cubed. That is 3. It's indicating that answer is in 3 dimensions. Okay, or it's derived using 3 dimensions. Anything else? Example 4. Example 4 is on page? What? 78? 3? Same, oh, same page. Same page. And now the question says, calculate 2 possible values for G. It's the G. Okay. Correct to the nearest whole number. We are also told that the area of triangle FGH is 68 centimeters squared. We are told that FG is 12 and GH is 14. So people, do we have 2 lengths in the included angle? That's the included angle that I must calculate. Not so. So let's go with the area here. What it would be? Area is equal to half GF or FG times GH sine of angle G. And angle G is the angle we must work out, not so. So what's the area of this triangle? 68 is equal to half times FG 12 times 14 sine of. How do I get sine of g on its own? Divide by half times 12 times 14 both sides. So that cancels, people. Not so. So sine of g is equal to 68 over 0.5 times 12 times 14 gives you 17 over 21 or 0.8095. Okay. 17 over 21. How do we get g on its own? Oxide. People, why do they tell you there is two possible solutions for g? Say?
It's probably an isosceles.
Isosceles. You're on the right track, but not isosceles necessarily. Okay, so if you get it, you can follow it up. Okay. So we say, okay, if this was in general solution, okay, what would we have done? We would have asked ourselves, in which quadrant is sine? Positive. Which is quadrant 1 and 2. So let's go with quadrant 1. So in quadrant 1 it would be arc sine, we just get a reference angle here quickly. Your reference angle G is going to be arc sine. Arc sine, and the answer gives you 54,05. So it's 54 degrees. Okay. So in quadrant 1, what would it be? 54 degrees. Not so. Must I go with plus k times 360 here? Why not? Huh? The triangle. If it's going to say plus 360, it's going to take you out of the fold of a triangle. The triangle won't exist to us. Not so? Or in quadrant 2. What would it be in quadrant 2? 180 minus 54. None of you still get it. 126. What do you notice about this? This is, what type of angle is this? Acute angle. This is an obtuse angle. Can you see that, people? So, this, if I draw the triangle, a similar triangle with a similar length there, with the same length, one of 12 and one of 14. That angle with an area of 68 centimeters square will exist at an angle of 126 degrees. Can you see that? The answer I was looking for earlier on was, it's either the triangle could be an acute triangle or the angle could be an obtuse triangle. You guys understand? And that is the examples for exercise 10.2. Tomorrow's lesson we will look at solving triangles, that is non-right angle. We will then delve into the sine rule and the cosine rule. Okay. So for homework is exercise 10.2. You're going to do for me the odd numbers. Okay. There's something with regards to 10.2. I know you're going to do number 1, number 3, number 5. But number 5, from A to F is testing the same thing. So in number 5, you do A, C, and E. Okay. Then I brought number 6 in, A, C, and then 7, A, C. Number 9 again, 11, and so on. So you guys got it? You have it, Michael? Okay. The full lesson can be found in the description box below.